Welcome to Brain Vision.
So let's draw a diagram of the H2O molecule. We have an oxygen molecule here. It has a bent shape, so this would be the hydrogen molecule. And this would be the other hydrogen molecule. We could say that this is an angle defined theta. We could say that this distance here would be considered L, and this distance here would be considered L sub y. And we could say that the mass of a hydrogen atom is going to be equal to 1.01 atomic mass units, or we can say 1.66 times 10 to the negative 27th kilograms. Since the axis passes through the oxygen atom itself will have no rotational inertia. Therefore, when calculating for the moment of inertia, do not account for the mass of the oxygen atom, because this would be the axis of rotation. So we can say that if the axis is perpendicular to the plane of the model, then each hydrogen atom is a distance L away from the axis of rotation. Therefore, the moment of inertia through the perpendicular axis, or we can simply say perpendicular axis, this would be equal to 2 times the mass of the hydrogen atom times L squared, because there are 2 hydrogen atoms. Therefore, I perpendicular would be equal to 2 times, we actually said 1.01 atomic mass units, where 1 atomic mass units is 1.66 times 10 to the negative 27th kilograms per atomic mass unit. So this would be multiplied by 1.01. My apologies. So this would be 2 times 1.01 times 1.66 times 10 to the negative 27th kilograms. Multiplied by that length of 0.96 times 10 to the negative 9th meters, quantity squared. And we have that the moment of inertia through the perpendicular axis would be 3.1 times 10 to the negative 45th kilogram squared. And this would be your answer for part A. For part B, however, the axis of rotation now is in the plane of the molecule. So for part A, the axis of rotation was through the oxygen molecule. Now, this would be the axis of rotation for B. This essentially going inside the page. This would be the axis of rotation for part A. Either way, you don't account for the mass of the oxygen atom, because the distance between the oxygen atom and the axis of rotation for both cases is going to be 0. So you do not account for that in the moment of inertia. And for part B now, the axis of rotation is bisecting the plane of the molecule. Therefore, we can say that L sub y would be equal to L sine of theta, and this would be equal to 9.6 times 10 to the negative 10th multiplied by sine of 52 degrees. This is giving us 7.564 times 10 to the negative 10th meters. So essentially, when the axis of rotation is in the plane of the atom, we have to use L sub I, because now the distance between the hydrogen atom and the axis of rotation decreases a bit. So we can say that the moment of inertia through the plane of the atom would be equal to 2 times the mass of the hydrogen atom times L sub y squared. And so this would be equal to 2 times, again, 1.01 times 1.66 times 10 to the negative 27th kilograms, multiplied by 7.564 times 10 to the negative 10th meters, quantity squared. And we find that the moment of inertia, when the axis of rotation is through the plane, is in the plane of the H2O molecule, this would be equal to 1.9 times 10 to the negative 45th kilogram meters squared. So this would be our answer for part B. That is the end of the solution. Thank you for watching.